the center of those black holes. So they would use stars as gateways to go from one side of the galaxy to the other. And then you would expect them to be called sun gods. That is why, for instance, the ancient tradition in most of these countries talks about the sun as the doorway to the higher realm where the sun gods come from. They talk about the black hole at the center of our galaxy as the hub, the central sun, from which you can access all of the stars in the galaxy. So you would enter the sun and then through to the galactic center, out one of the arms of the galaxy, out one of the sun in another arm of the galaxy. This is the sun as it looks normally. On the sun appears sunspots. These are sunspots. Actually, there are sunspots seen at the X-ray range level. So they appear very bright. Actually, sunspots in the optical spectrum are very dark. They're like black. Well, they appear when the sun becomes very active at 19.47 latitude north and south. Okay? And when you look at the sunspot carefully, and I picked this one because I believe that sunspots are at the heart of the matter. When you look at it carefully, you can see that the fire is being sucked in. That's what made me think, actually, from my calculation and from my theory and all this, that the sunspots on the sun are not surface events, but they're huge vortices going to the middle of the sun. The other reason, can you see the fire being sucked in here? I got in a lot of trouble for saying that. Because they said, no, it's just surface event. And I said, well, if it's just surface event, how come if you look at the sunspots on the sun, they always occur in opposite polar. See? This one here got an opposite one there. These three there have an opposite three there. You see? All the sunspot occurs in opposition to each other, because when you have a vortex going one way in the Coriolis effect, you have another one going the other way on the other side. And they generate a link at the middle, a link at singularity. Sunspots are huge vortices going towards singularity at the center of the black hole. And that's why when you look at sunspots very carefully, you see fire being sucked in. The sunspots are actually break through the event horizon of the black hole of the sun, where you can actually see the collapsing black hole pulling the electromagnetic field in. Well, when I was saying this, I was being ridiculed. Recently, this is what they found.
Awesome plasma hurricanes were one of the surprises revealed when scientists recently peered beneath the stormy surface of our star. November 7, 2001. Using techniques similar to medical ultrasound, scientists have peered inside the sun and discovered what lies beneath sunspots, planet-sized dark areas on the surface of our star. Astronomers have long known that sunspots are regions where magnetic fields become concentrated. Yet anyone who played with magnets as a child has felt how magnetic fields of like polarities repel each other. Likewise, the strong magnetic fields of sunspots should naturally repel each other too, causing the sunspot to quickly dissipate. Indeed, observations show that surface material clearly flows out of the spots. What then makes sunspots so long-lasting? How do they remain intact for weeks and months? A team of scientists had to look beneath the surface of the sun to find the answer. Alexander Kosovichev and Junwei Zhao of Stanford University, along with Thomas Duvall of NASA's Goddard Space Flight Center, used MIDI's unique ability to probe the happenings just below a sunspot surface, and for the first time, they have clearly observed inward-flowing material. We discovered that the outflowing material was just a surface feature, said Zhao. If you can look a bit deeper, you find material rushing inward, like planet-sized whirlpools or hurricanes. This inflow pulls the magnetic fields together. The cool downward flows dissipate at the same depth where the hot upward flows diverge, explained Duvall. With these data, one cannot get a sharp enough picture to really explain the details. Until now, we've looked down at the top of sunspots like we might look down at the leaves and treetops. For the first time, we're able to observe the branches and trunk of the tree that give it structure. The roots of the tree, however, remain a mystery.
That's for you guys. Now, so they started to see now that the sunspot, which some of them are like 14 times the size of the Earth, okay, are huge vortices going towards the middle. And when they talk about material being spit out of the sunspot, do you guys know what material that is? Water. Large amount of water comes out of sunspots on the sun, right beside the fire.
Is that their conclusion?
No, that's measurements. Pardon me?
Is that their conclusion?
That's their measurements of the material that's coming out, mostly water. Well, steam, you know, H2O. Yeah, it's spectroscopy. But then, you know, so then I was thinking about that. I'm like, okay, well, you know, if you were to travel through the universe, and everything in the universe is a singularity, then you could, you know, build a ship that's able to go inside a singularity. That ship would have to have a drive at its center that's a singularity itself. Okay? And you could enter a local singularity, and because you're in singularity, connected to all things, you could come out anywhere you want, anywhere else in the universe. And you could actually follow a linear progression of that travel. Although it would only take seconds for you to go across the galaxy, you would still go through the singularity of the sun, through the singularity of the hub, and then out to another singularity that would be a solar system in some other corners of the galaxy. You could even go from the hub to another galaxy hub and then come out wherever you want there. You guys are following this? Yeah. Okay. Now, if you think of it this way, then it's like, okay, well,